Yes, we are going to start 11.6. I'm going to present my screen. Eleven 11.6 deals with the three things. One is absolute convergence. The other two are ratio test and root test. Okay, first we will discuss the absolute convergence. Sigma n varies from 1 to infinity an is said to be absolutely convergent if sigma n varies from 1 to infinity, absolute value of n is convergent. So, result number 2, sigma n varies from 1 to infinity. An is conditionally convergent if it is convergent but not absolutely convergent. See, it is convergent because of the, or if it is an alternate series, then you know we have seen the method of testing the convergence of an alternative series. And if it is convergent but not absolutely convergent. So here is one example. Sigma n varies from 1 to infinity, negative 1 to the power of n minus 1 times 1 over n. This is 1 minus 1 over 2 plus 1 over 3 minus 1 over 4 plus 1 over 5 minus etc. It is convergent because limit n approaches infinity 1 over n, that is bn. Bn is 1 over n. Limit n approaches infinity 1 over n is 0 and 1 over n plus 1 is less than 1 over n because the denominator of the left side is greater than the denominator of the right side. So the whole expression is less than 1 over n. But sigma 1 to infinity absolute value of an is equal to sigma n varies from 1 to infinity 1 over n is divergent because of the p-test. P is equal to 1 here. You know, if p is less than or equal to 1, it is divergent. So in this case, this is divergent. So sigma 1 to infinity negative 1 to the power of n times 1 over n is convergent but not absolutely convergent. That is known by the name, it is conditionally convergent. Example, this is example, yeah, that's the second result. Okay, third result. If sigma 1 to infinity, n varies from 1 to infinity, an is absolutely convergent, then sigma 1 to infinity, an is convergent. But the converse is not true. That is, if sigma n varies from 1 to infinity, an is convergent, need not guarantee that it is absolutely convergent. So that example 2 here this is convergent. Like an example, this one, sigma 1 to infinity, negative 1 to the power of n minus 1 times 1 over n is convergent, but it is not conditionally, it is not absolutely convergent. But absolutely, if it is absolutely convergent, it must be convergent. So that is the difference between result number 2 and 3. Okay, this is question number 2 from the text. Determine whether the series sigma 1 to infinity negative 1 to the power of n minus 1 divided by square root of n is absolutely convergent or conditionally convergent. An is equal to negative 1 to the power of n minus 1 whole divided by square root of n, and so bn is 1 over square root of n. We are going to test the apply the test for alternating series. Limit n approaches infinity, bn is equal to limit n approaches infinity 1 over square root of n, which is 1 over infinity, which is 0. So first condition is met. 1 over square root of n plus 1 is less than 1 over square root of n because denominator of the left side is greater than denominator of the right side. So the whole expression, that fraction, is less than 1 over square root of n. That is bn plus 1 is less than bn. Therefore, sigma n is convergent. Now we are going to see whether it is absolutely convergent. Sigma 1 to infinity, absolute value of an is equal to sigma 1 to infinity 1 over square root of n, which is sigma 1 to infinity 1 over n to the power of 1/2 is divergent because of the p-test. In this case, p is 1/2, which is less than 1. So it is not absolutely convergent, but it is convergent. So that means sigma n is conditionally convergent. Number 4. Sigma n varies from 1 to infinity, negative 1 to the power of n divided by n cubed plus 1. So Bn is equal to 1 over n cubed plus 1, and that is less than 1 over n cubed. Why? Because the denominator of the left side, that is n cubed plus 1, is greater than n cubed. And so sigma Bn is equal to sigma 1 over n cubed plus 1 less than sigma 1 over n cubed. So our right hand side is convergent because of the p-test. P is 3, which is greater than 1. Therefore, sigma n is convergent. And sigma n is absolutely convergent and sigma n is convergent. So in this case, it is absolutely convergent. If it is absolutely convergent, then you don't have to apply the test for alternating series. In this case, it is we applied the comparison test. 1 over n cubed plus 1 is less than 1 over n cubed. And so sigma 1 over n cubed plus 1 is less than sigma 1 over n cubed. What is the right side is convergent because of the p-test. And what is 1 over n cubed plus 1? That is absolute value of an. So it is absolutely convergent. Since sigma n is absolutely convergent, it is convergent. Number 6. Sigma n varies from 1 to infinity, negative 1 to the power of n minus 1 times n over n square plus 4. Bn is n over n square plus 4. So limit n approaches infinity, Bn is equal to limit n approaches infinity, n over n square plus 4. That is limit n approaches infinity, 1 over n plus 4 over n. That is, you divide numerator and denominator by n. This is 1 over infinity plus 0, that is 1 over infinity, which is 0. So the limit is 0. And now we are going to see whether it is a decreasing sequence. For that, we are applying calculus here. You might draw the graph also and see. So let fx is equal to x over x square plus 4. Bn is n over n square plus 4. So fx must be x over x square plus 4. You use calculus. First derivative is x square plus 4 times 1 quotient rule minus x times derivative of x square plus 4, that is 2x divided by x square plus 4 the whole square. This is negative x squared. See, this is minus 2x squared plus x squared, that is minus x squared plus 4 divided by x squared plus 4 the whole square. I'm going to pull out a negative sign from the numerator. So negative x squared minus 4 divided by x squared plus 4 the whole square. Denominator is always positive. So this is negative. The whole expression is negative when x squared minus 4 is positive. That is when x squared is greater than 4. And since we don't consider the negatives, x must be greater than 2. So fx is a decreasing function whenever x is greater than 2. Therefore, Bn is a decreasing function when n is greater than 2. Therefore, sigma negative 1 to the power of n times n over n squared plus 4 is convergent by the alternating series test. Now we are going to see whether this is absolutely convergent. Sigma 1 to infinity, absolute value of an is sigma 1 to infinity n over n squared plus 4. So we are going to use the comparison test here. So let limit comparison test here. You discard all the non-dominating terms. So plus 4 is discarded. You got another sequence. You cannot call an because an is already used here. So I'm going to use the word Cn. So Cn is 1 over n. How you get it? Discard the plus 4. It becomes n over n square. So 1 n over n square is the same as 1 over n. Therefore, Pn over Cn is n over n square plus 4 divided by 1 over n. That is n over n square plus 4 times n over 1. That is n square over n square plus 4. Divide numerator and denominator by n square. You get 1 over 1 plus 4 over n square. Therefore, limit n approaches infinity, Bn over Cn is limit n approaches infinity 1 over 1 plus 4 over n square. 4 over n square is 4 over infinity, that is 0. So it is 1 over 1 plus 0. Answer is 1. Positive and finite. And therefore, they behave the same way. If sigma Cn converges, sigma Bn converges. If sigma Cn diverges, sigma Bn also diverges. But sigma Cn is equal to sigma 1 to infinity 1 over n is divergent. Why? Because of the p-test. So since sigma Cn is divergent, sigma Bn is divergent. That means this is not absolutely convergent. Sigma an, absolute value of an is not convenient, means sigma an is not absolutely convergent, but it is conditionally convergent because the alternating series test, it passes that test. Now there comes a test called a ratio test. Here is the ratio test. If limit n approaches infinity, absolute value of an plus 1 divided by n plus 1 the term divided by the nth term is less than 1, then sigma an is convergent, and if it is an alternating series, it is absolutely convergent. And if that limit is greater than 1, it is divergent. If limit n approaches infinity, absolute value of an plus 1 over n is greater than 1, then sigma n is divergent. If limit n approaches infinity, absolute value of an plus 1 over an is equal to 1, then no conclusion. We have to look for some other method. So this ratio test is another efficient test for convergence. So if the limit n approaches infinity of absolute value of an plus 1 over n, even an plus 1 over an is less than 1, then sigma 1 to infinity an is convergent. If it is an alternate series, it is absolutely convergent. Similarly, if limit n approaches infinity, an plus 1 over an is greater than 1, then sigma n varies from 1 to infinity, n is divergent. But if that limit is equal to 1, no, you cannot conclude anything. Sometimes it converges, sometimes it diverges. You have to apply some other test. Okay, now question number 8. Sigma 1 to infinity, negative 2 whole to the power of n over n square. So an is negative 2 to the power of n over n square. N plus 1 is replace n by n plus 1, negative 2 to the power of n plus 1 divided by n plus 1 the whole square. Therefore, an plus 1 over an is equal to negative 2 to the power of n plus 1 divided by n plus 1 the whole square divided by negative 2 the whole to the n divided by n square. Division by a fraction is the reverse multiplication by its reciprocal. So this is negative 2 to the power of n plus 1 divided by n plus 1 the whole square times n square over negative 2 to the power of n, that is negative 2 to the power of n plus 1 over negative 2 to the power of n is negative 2 to the power of 1. So that is negative 2 n square over n plus 1 the whole square. Therefore, absolute value of n plus 1 over n is 2n square over n plus 1 the whole square. You know, absolute value is always non-negative. So limit n approaches infinity, absolute value of n plus 1 over n is equal to limit n approaches infinity 2n square over n plus 1 the whole square you divide both sides by n square. Both sides means both numerator and denominator. So this is limit n approaches infinity, numerator is 2, denominator is n plus 1 over n, which is 1 plus 1 over n square. Wow, this is whole square. I'm sorry about that. This is 1 plus 1 over n, the whole square it is here. It is not 1 plus 1 over n square. This is 1 plus 1 over n, the whole square. But that will not affect the final answer. So that limit is 2 divided by 1 plus 0, the whole square. That is 2 divided by 1, which is greater than 1. So the series is divergent. So that series is divergent. Next, sigma and varies from 0 to infinity. You keep in mind, 0 to infinity. Negative 3 to the power of n divided by 2n plus 1 factorial. So an is negative 3 to the power of n divided by 2n plus 1 the whole square, and an plus 1 is negative 3 to the power of n plus 1 divided by 2 times n plus 1 plus 1. You are replacing n by n plus 1. So negative 3 to the power of n plus 1 divided by 2n plus 3. You distribute the 2 times n plus 2 times 1 plus 1. So 2n plus 3 factorial. An plus 1 over n is negative 3 to the power of n plus 1 divided by 2n plus 3 factorial divided by negative 3 to the power of n divided by 2n plus 1 the factorial, that is negative 3 to the power of n plus 1 over 2n plus 3 factorial times 2n plus 1 factorial over negative 3 to the n, that is negative 3 times 2n plus 2 times 2n plus 3. Why? Because I have shown that work here. See, 2n plus 1 factorial over 2n plus 3 factorial is numerator 1 times 2 times 3 times up to 2n plus 1. Denominator 1 times 2 times 3 times etc. up to 2n plus 3. What is the number just before that? That's 1 less than this. So that is 2n plus 2. What is the number just before that? That is 1 less than this. That is 2n plus 1. So all the terms up to 2n plus 1 cancels, and there will be a 2n plus 2 times 2n plus 3 in the denominator, and that is this one. Okay. Now, absolute value of an plus 1 over an is 3 divided by 2n plus 2 times 2n plus 3. The limit is 0 because as n approaches infinity, this is 3 over infinity times infinity, which is less than 1. And therefore, the series is convergent. It is absolutely convergent. 12. Sigma k varies from 1 to infinity, k e to the negative k. And I think we have seen this in one of the earlier sections. Anyhow, ak, the kth term is k e to the negative k. So ak plus 1 is k plus 1 times e to the negative k plus 1. That is k plus 1 times e to the negative k times e to the negative 1. Therefore, ak plus 1 over ak is k plus 1 times e to the negative k times e to the negative 1 divided by k times e to the negative k. That is k e to the negative k cancels. So k plus 1 e to the negative 1 over k, that is k plus 1 over k is k over k plus 1 over k. So that is 1 plus 1 over k times e to the negative 1 is 1 over e. Now you find the limit. So limit k approaches infinity, ak plus 1 over ak is equal, absolute value of ak plus 1 over ak is equal to limit k approaches infinity, 1 plus 1 over k times 1 over e. And the 1 over k is 1 over infinity, that is 0. So it is 1 times 1 over e, and you know e is approximately 2.718. Therefore, this 1 over e is 1 over 2.718, so that is less than 1. Since it is less than 1, the given series is absolutely convergent. Number 14. Sigma n varies from 1 to infinity, n factorial divided by 100 to the power of n. This is not an alternating series, so you don't have to worry about that part. An is equal to n factorial over 100 to the power of n. N plus 1 is n plus 1 factorial over 100 to the power of n plus 1, which is n factorial times n plus 1, because n factorial is product of numbers from 1 to n. N plus 1 factorial is product of all the numbers up to n plus 1. That means it is n factorial times n plus 1 factorial. 100 to the power of n plus 1 is 100 to the power of n times 100 to the power of 1. So n plus 1 over n is n factorial times n plus 1 divided by 100 to the power of n times 100 divided by n factorial over 100 to the power of n, that is n factorial times n plus 1 divided by 100 to the power of n times 100 multiplied by 100 to the power of n over n factorial, and n factorial cancels, 100 to the n cancels. You have n plus 1 over 100. Limit n approaches infinity. Absolute value of n plus 1 over n is limit n approaches infinity. N plus 1 over 100. When n is infinity, this is infinity, so it is more than 1. Therefore, the series is divergent. See, whenever a factorial is there, this test, that is the ratio test, will be appropriate. Question number 16. N varies from 1 to infinity, n to the power of 10 divided by negative 10 to the power of n plus 1. So an is n to the power of 10 over negative 10 to the power of n plus 1. N plus 1 is n plus 1 to the power of 10 divided by negative 10 to the power of n plus 1 plus 1, that is n plus 2. So n plus 1 over n is n plus 1 to the power of 10 divided by negative 10 to the power of n plus 2 divided by n to the power of 10 divided by negative 10 to the power of n plus 1. That is n plus 1 to the power of 10 divided by negative 10 to the power of n plus 2 times the reciprocal, that is negative 10 to the power of n plus 1 divided by n to the 10. Now you cancel the common factors. You get this is n plus 2 and here numerator n plus 1. So there is one extra negative 10 in the denominator. That is why you have negative 10 there. Then n plus 1 to the power of 10 divided by n to the power of 10. And so this is 1 plus 1 over n to the power of 10. That 10 is missing here. So that is negative. It is negative. Therefore, negative 1 plus 1 over n to the power of n times 1 over 10. Therefore, limit n approaches infinity. Absolute value of n plus 1 over n is equal to limit n approaches infinity 1 plus 1 over n to the power of 10. That 10 is missing here also. Please correct it. Times 1 over 10. But that will not affect the answer. That is the reason why I don't give much attention on that, because I know it is going to be convergent. So 1 plus 1 over n to the power of 10, which is 1 plus 0 to the power of 10, which is 1. 1 times 1 over 10, that is less than 1. Therefore, sigma n is absolutely convergent. Number 18. N is equal to n factorial over n to the power of n. N plus 1 is equal to n plus 1 factorial divided by n plus 1 to the power of n plus 1. Therefore, n plus 1 over n is n plus 1 factorial over n plus 1 to the power of n plus 1 plus, divided by n factorial divided by n to the n. That is n plus 1 factorial divided by n plus 1 to the power of n plus 1 times the reciprocal n to the n divided by n factorial. So, n plus 1 factorial divided by n factorial is actually n plus 1. So that is why this n plus 1 is there. N plus 1 times n to the power of n denominator. N plus 1 to the power of n plus 1, that is n plus 1 times n plus 1 to the n. N plus 1 cancels. So this is n over n plus 1 whole to the power of n. This is 1 n over n plus 1 to the power of n. This is 1 divided by, you divide both numerator and denominator by n. So 1 divided by 1 plus 1 over n whole to the power of n. Now find the limit. So limit n approaches infinity, an plus 1 over an is equal to limit n approaches infinity, 1 over 1 plus 1 over to the power of n. That this is the definition, one of the definitions of e, the exponential constant. So exponential function is e to the power of x is 1 plus x over n whole to the power of n. If x is 1, this is e to the 1, which is e. 1 over e is 1 over 2.718, which is less than 1. So sigma an is absolutely convergent. Number 20. Sigma 2n factorial divided by n factorial square. An is equal to 2n factorial divided by n factorial square. So an plus 1 is equal to 2 times n plus 1 factorial. You are replacing n by n plus 1. 2 times n plus 1 factorial divided by n plus 1 factorial. That is equal to, distribute to 2n plus 2 factorial over n plus 1 factorial. Therefore, an plus 1 over an is equal to 2n plus 2 factorial over n plus 1 factorial square, that is this part. N plus 1 factorial square is there, that square is missing here. Divided by 2n factorial divided n factorial square. So this is 2n plus 2 factorial divided by n plus 1 factorial times n plus 1 factorial, because that's a square, multiplied by n factorial square divided by 2n factorial. Now that is 2n plus 2 factorial divided by 2n factorial times n factorial times n factorial, that is n factorial square, divided by n plus 1 factorial times n plus 1 factorial. So this is 2n plus 1 times 2n plus 2, because terms up to 2n cancels. What is 2n factorial? 2n factorial is 1 times, 2 times, 3 times up to 2n. 2n plus 2 factorial, 1 times, 2 times, 3 times, etc. 2n times 2n plus 1 times 2n plus 2. So terms up to 2n plus 1 cancels. And here, n plus, and this one is 1 over n plus 1 will be there, n factorial cancel, so there is a 1 over n plus 1 square here, and so the limit is equal to, I think the question number 20 there is a mistake. I will rework question number 20 and post it shortly, because there is 2 terms are missing here. So I think this is convergent. So please discard question number 20 worked out here. I will work it out and post it separately. Now there comes the root test. The root test. If limit n approaches infinity, an to the power of 1 over n is less than 1, then sigma an is absolutely convergent. If it is greater than 1, it is divergent. If it is equal to 1, no conclusion. So just like the ratio test, root test behaves the same way. Number 26. Sigma n varies from 1 to infinity, negative 2 to the power of n whole to the power of, or divided by n to the power of n. So n is negative 2 to the power of n over n to the n. Therefore, n to the power of 1 over n is negative 2 over n. Limit n approaches infinity, absolute value of an to the power of 1 over n is limit n approaches infinity, 2 over n, which is 0, that is less than 1. Therefore, sigma n is absolutely convergent. Number 28. Sigma 1 to infinity, negative 2n over n plus 1 whole to the power of 5n. that is an is equal to negative 2n divided by n plus 1 to the power of 5n. Therefore, an to the power of 1 over n is negative 2n over n plus 1 to the power of 5. You have to divide the exponent by n. Therefore, limit n approaches infinity, absolute value of an to the power of 1 over n is limit n approaches infinity 2n over n plus 1 whole to the power of 5, because negative sign will go. And that is divide the numerator and denominator by an n. So limit n approaches infinity, 2 over 1 plus n whole to the power of 5, that is 2 to the power of 5, which is 32. That's greater than 1. Therefore, the series is divergent. Sigma 1 to infinity tan inverse n to the power of n. So an is equal to tan inverse n to the power of n. An to the power of 1 over n is tan inverse n. Therefore, limit n approaches infinity, absolute value of an to the power of 1 over n is equal to limit n approaches infinity tan inverse n, which is tan inverse infinity, which is pi over 2. Pi is 3.14. So pi over 2 is greater than 1. So the series is divergent. Okay, next is 32. Limit sigma 1 to infinity 1 minus n over 2 plus 3n whole to the power of n. An is 1 minus n divided by 2 plus 3n whole to the power of n. Therefore, n to the power of 1 over n is 1 minus n divided by 2 plus 3 over n, and divide all the 4 terms by n. It becomes 1 over n minus 1 divided by 2 over n plus 3. And now find the limit. When you find the limit, as n approaches infinity, an to the power of 1 over n is equal to limit n approaches infinity, absolute value of 1 over n minus 1 divided by 2 over n plus 3, which is 0 minus 1 over 0 plus 3, absolute, that's negative 1 over 3, absolute value is 1 over 3, that is less than 1. So the series is convergent. The last question from that section. Sigma 1 to infinity sine n pi over 6 divided by 1 plus n square root of n. Here you have to use the comparison test first, because whenever sine and cosine are involved, you know sine lies between negative 1 and positive 1. So here sine n pi over 6 is less than or equal to 1. Therefore, sine n pi over 6 divided by 1 plus n square root of n is less than or equal to 1 over 1 plus n square root of n, and that is less than 1 over n square root of n, because denominator of 1 over 1 plus n square root of n is more than the denominator of the second. So this is equal to 1 over n to the power of 3 halves. So an is less than 1 over n to the power of 3 half, and therefore sigma 1 to infinity an is less than sigma 1 to infinity 1 over n to the power of 3 half. Right side converges because of the p test. P is 3 half, which is more than 1, and therefore left hand side converges. That's it. And number 20 I will work out. So please discard number 20, because I missed 2 terms here. And so I will work out number 20 and post it separately, not as a video, but I will work out that and show it. Okay, so that is all from 11.6.